My name is Dr Goldberg. I'm Executive Vice President for Medical and Regulatory Strategy at Synageva Biopharma. We're studying lysosomal acid lipase deficiency, which is an autosomal recessive disease due to mutations in both alleles of the gene that encodes lysosomal acid lipase. This enzyme is critical in cholesterol metabolism. When an LDL particle binds to the LDL receptor and gets taken up by the cell, the cholesterol esters and the triglycerides within the particle are hydrolyzed within the lysosome into free cholesterol and free fatty acids. And when this enzyme is deficient or absent, there's a dramatic increase in the amount of lipids that accumulate in the lysosomes of the cells throughout the body, but particularly in cells of monocyte macrophage lineage and hepatocytes. This leads to progressive accumulation of fat and steatosis in the liver, usually a microvesicular steatosis, that progresses to fibrosis and cirrhosis, and leads often to liver failure even in childhood. There's also a dyslipidemia marked by a high LDL and a low HDL and a variably elevated triglycerides that leads to accelerated atherosclerosis. First of all, extensive preclinical data and a very relevant animal model that showed by giving a recombinant human enzyme to replace the deficient lysosomal acid lipase, we could get the enzyme to bind to mannose and mannose 6-phosphate receptors on cells, get internalized, traffic to the lysosome, and replace the missing enzyme. We showed that we could reverse the fatty accumulations in the liver in this animal model. We could improve growth in the animals and improve survival. We've now moved into a phase 1/2 clinical trial that is described in this poster. In that study, we studied 8 adults over 90 weeks being treated with the enzyme, and we showed that with every other week treatment, we could see a dramatic decrease in the previously elevated transaminases. They started elevated, they came down into the normal range, and they remained in the normal range during this 90-week period. Similarly, with replacing the missing enzyme, we see a mobilization of the accumulated lipids. So once the triglycerides and the cholesterol esters are hydrolyzed, we initially see the mobilization as evidenced by a transient rise in cholesterol and triglycerides, but with continued treatment, these decrease to below baseline levels, and by 90 weeks, we see about a 50% reduction in LDL cholesterol compared to the original baseline, a similar decrease in triglycerides, and a modest rise in an HDL as well. The study is now ongoing, and we have a phase 3 trial in children and adults that's now fully enrolled and is maturing at this time. We hope to have data from that trial in the latter part of this year.